In this session, we are going to discuss Gray code. It is developed by Frank Gray, hence the name Gray code. It is an unweighted code. That means there is no positional weight in Gray codes. It is a case of reflective code, and Gray codes are also known as unit distance code, which is an important property of Gray code. In unit distance code, if we take any two successive codes, they are differ only by one bit. So this table shows the gray code representations for the decimal digit 0 to 15. So if you want to get the gray code representation, first we need to convert the decimal digit into the binary representation, and from binary we need to convert into gray. So binary to gray and gray to binary conversions we'll discuss later. So now let us understand what is the unit distance property of gray code. So in gray code, if you take any two adjacent codes, they differ only by one bit. For example, if you take the binary of 3 and 4, binary of 3 is 0011, binary of 4 is 0100. How many bit changes we can observe here? 0 to 0 no change, 0 to 1 changed, 1 to 0 changed, again 1 to 0 changed. So total 3 bit changes we can observe here. But at the same time, 0010 is the gray code for 3 and 0110 is the gray code for 4. Here how many bit changes we can observe? 0 to 0 no change, 0 to 1 changed, 1 to 1 no change, 0 to 0 no change. So only one bit change is required to switch from the decimal number 3 to 4 in gray code. Now we'll see one more example, 7 and 8. What is the binary of 7? 0111 and binary of 8 is 1000. How many bit changes are there? 4 bit changes we can observe here. But at the same time in gray code, 0100 is the gray code for 7, 1100 is the gray code for 8. Again only one bit change we can observe here. That means in gray code, if you take any two adjacent codes, they are differ only by one bit, and that is known as the unit distance property of gray code. Next, we will see how to convert a gray code to binary code. So the first step is to write the MSB of binary as same as the MSB of gray. And the second step, for getting the next binary bit, we have to perform the XOR operation with the bit just written down and the next gray bit. Then repeat step 2 until all the gray bits are converted into the respective binary bits. So before going to the conversion, first we will see what is the XOR operation. So this is the truth table of XOR gate. For 2 input XOR gate, if the inputs are 0 0, output is 0. For 0 1 1, 1 0 1, 1 1 0. So this is actually binary addition neglecting the carry. That means 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 0, carry 1, we are neglecting the carry. Now we will see an example for gray code to binary conversion. The given gray code is 1010 that we are writing as it is. Now the first step is to write the MSB of binary as same as the MSB of gray code. So here the MSB is 1. So writing MSB of binary also as 1. Now the next bit in binary we will get by the XOR operation between the bit just written down with the next gray bit. That means 1 XOR 0. What is 1 XOR 0? 1 that we are writing here. That is the next binary bit. Now the next binary bit will get by the XOR operation with this bit written down with the next gray bit. That means 1 XOR 1. 1 XOR 1, 0. We got the next binary bit. Now the next bit, XOR operation of this 0 and with the next gray bit. So 0 XOR 0, answer is 0. So the resultant binary code is 1100. Let us see one more example for the gray to binary conversion. So the gray code given is 0111, 0111, that we are going to denote it as G0, G1, G2, G3. And after conversion, in the resultant binary also, there will be 4 bits, and that we are going to denote it as B0, B1, B2, B3. Now how we can convert gray to binary? First step is to write the MSB same as MSB of binary. So here the MSB is 0, that we are writing as MSB in binary. Now the next bit in binary will get by the XOR operation of this previous resultant bit with the next gray code bit. That means 0 XOR 1. 0 XOR 1 is 1. Then the next binary bit 1 XOR 1, 0. Then 0 XOR 1, 1. So the resultant binary code is 0101. Now with this operation, we can actually develop the equations for converting the gray to binary for 4 bits. So here B3 is equal to G3. Then how we are getting B2? B2 is equal to B3 XOR G2. Then B1 is equal to B2 XOR G1. And B0 is equal to B1 XOR G0. And using these equations, we can design a gray to binary converter circuit also. Now we will learn how to do binary to gray conversion. So these are the steps for the conversion of binary to gray code. The first step is to write MSB of the gray code as same as the MSB of binary. Then the second step is to obtain the next gray bit, perform XOR operation between the previous and current binary bits. And then we need to repeat this step 2 until all the binary bits are converted into the respective gray codes. For example, if you want to convert the binary code 1010 to gray, first we need to write the binary as it is 1010. Then the first step is to write the MSB of binary as the MSB of gray. Here the MSB is 1, so the MSB of gray is also 1. Now the next gray bit we are getting by the XOR operation between the previous and the current binary bits. That means 1 XOR 0. What is 1 XOR 0? 1. So that is the next gray bit. Now the next gray bit we are getting by the XOR operation of previous and current binary bits. That means 0 XOR 1. What is 0 XOR 1? 1. Now the next bit between this previous and current, that means 1 XOR 0, 1. So this is the resultant gray code for the binary code 1010. We'll see one more example for binary to gray conversion. The binary code given is 1001. 4 bits are there that we are going to denote it as B0, B1, B2, B3. And the resultant gray also will have 4 bits that we are going to denote it as G0, G1, G2, G3. Now how we can convert binary to gray? First step is to write the MSB as it is MSB in gray. So here the MSB is 1. In the gray also we are writing MSB as 1. Now the next bit by the XOR operation between the previous and current binary bits. That means 1 XOR 0. 1 XOR 0, 1. Next 0 XOR 0, 0. Then 0 XOR 1, 1. So this is the resultant gray code. 1101 is the equivalent gray code for the binary code 1001. Now we are going to write the equations for the binary to gray conversion. So for the first gray bit G3 is equal to B3. G3 is equal to B3. Now next gray bit G2 is equal to B3 XOR B2. So G2 is equal to B3 XOR B2. And G1 is equal to B2 XOR B1. B2 XOR B1. And G0 is equal to B1 XOR B0. B1 XOR B0. So we got the equations, and using these equations we can design a binary to gray code converter circuit.